Hi, so for my research paper, I did immobilization of simulated borate radioactive waste solution in cement polymethacrylate composite, mechanical and chemical characterizations. The authors were H.M. Salah and H.A. Shatta, and it's presented by me, Carly's lady. In this research experiment, the principal waste materials that were generated from the PWRs, or pressurized water reactors, consist of hot aqueous concentrations of boric acid and their work cement polymethylmethacrylate, or PMMA, composite was used for the introduction of the waste to overcome the effects of the borate salts in case of direct cementation. The PMMA is an organic polymer that has been used as an effective additive to improve the properties of the cement waste forms, overall being better for the environment. It also increases durability and strength and decreases capillary flow of water. This experiment deals with the impregnation of cement blocks with the PMMA monomer having benzoyl peroxide as the initiator. The polymerization process is then completed by heating it at 40 degrees Celsius. They used several materials for this experiment. One was ordinary cement. The plain cement that was used was Portland cement, and it was the local available cement that they had available to them. Second was simulated waste solution. It was a simulated borate waste solution concentrate. Part of this waste was spiked with radioactive CS-137 and was used to evaluate the chemical characterization, as you'll see in the next slide. And then third was cement waste form, which was predetermined concentrations of the simulated borate waste solution that was mixed with OPC, which is ordinary Portland cement powder, which was the first original cement. This mixture was poured into the molds and left for 28 days to solidify. This slide is basically just showing you the chemical composition of that simulated borate waste solution, and that's just the concentration of it in grams per liters. So the first method that they used was called the heat suction technique. The MMA monomer was freed from the inhibitor by distillation under reduced pressure and was polymerized using the benzoyl peroxide as the initiator. And then the dried cement blocks were dried in the oven for 2 hours and then suctioned for 2 more hours. Then the blocks were flooded with the PMMA monomer containing the 3% benzoyl peroxide. After complete immersion, the system was returned to atmospheric pressure. After 24 hours, samples were then taken and allowed to polymerize at 40 degrees Celsius. And then on this side, there's just a schematic diagram of the apparatus that was used for this whole impregnation process. The second method that they had used was the leaching solution. The groundwater used for immersion is obtained from the Abu Zabal, one of the nearest groundwater wells. The prepared solidified waste specimens that were spiked with CS-137 were put in leaching jars and completely exposed. The whole jar was exposed to the same amount of immersion water. HESPI's leaching test was proposed by the International Atomic Energy Agency. This was chosen for this particular experiment and was followed. All of the leach data was prepared by using the cumulative leach fraction. So for changing of borate waste concentrations, borate waste contains mainly boric acid and some borate ions, which you can see in the following equation, which are known as cementation inhibitors. Boric acid and calcium hydroxide, which are produced during the cementation process, reacts as, and then this following equation. So this following table just indicates that the impregnation of the cement blocks with the PMMA improves the mechanical and chemical properties of all cement borate waste form due to the decrease in the porosity of the cement PMMA. So this table basically just shows you the different strengths of all the cements that they tested, and then on the side it says how long and for how many days they were immersed for. In conclusion, with both the mechanical and the chemical property outcomes, it could be said that using the PMMA as an impregnating matrix, using the heat suction technique, highly improves the tolerance of the cement matrix for incorporating the borate radioactive waste solution. So the whole point of this experiment was to improve the cement waste form and reduce the potential migration and dispersion of radionuclides from this waste form to the environment, which they successfully